Hey guys, so 9.6 is basically the wrap-up section for this chapter. We're going to skip 9.7 because it's kind of something totally different. There's plenty to deal with in this chapter as it is. So 9.6 here is just solving right triangles, right? So obviously the goal is just to solve a right triangle. Okay, basically what we're doing here is we're using all the material that we learned so far in this chapter, kind of putting it all together, and you have to use all of those tools to completely solve a right triangle. Okay, so when I say solve a right triangle, what I mean by that is find all angles and all sides. Okay, so that means for a triangle we've got 3 angles, we've got 3 sides, so that means there's 6 answers to every single one of these problems if I say solve a right triangle. Now, you are obviously going to be given some of those answers, so you're not going to have to actually find 6 answers every time. You're usually always going to be given 2 of the 6. Basically 3 of the 6, because you know one of the angles is always 90. But the tools you need to be able to use, obviously the Pythagorean theorem. All right, if you have that special case, you'll have to use the geometric mean, but usually you're not going to have that. Most likely you're going to have Pythagorean theorem, the special right triangle stuff, if you have a 30, 60, 90, or 45, 45, 90. And lastly, the most difficult one, the trig ratios. Okay, so I'm just going to go right into the example to show you how to do this. So the beginning of this, before I get into these actually solving right triangles problems, I want to just go through with you guys how to do the calculation of trig ratios in your calculator. Okay, so if you have you want to obviously have a calculator out. Now you have to have a calculator for this test. If you don't bring a calculator to this test, there's literally no way to solve these trig problems. Okay, so the first thing you want to do, if you're hopefully looking at your calculator in front of you, is make sure you're in degrees. Okay, so if you click mode, find mode on there. Right, somewhere under mode, there's going to be a selector area that you can choose between radian and degree. Right, sometimes it's in radian. We need to always be in degrees. So make sure you're in degrees, then you can clear out of the mode section. Right, now how to do this? Right, so if you just need to do a tangent of 17 degrees. Right, now that you're in degrees, you don't have to type degrees in anymore because it's already in now. Okay, so what you do is if you should search around, you should see a sine, cosine, and tangent button on your calculator. So to do that, the tangent of 17, you're going to find the tangent button on the calculator, click it. All right, you should have tangent with a parentheses. All right, so if you push the tangent button, you should see tan with a parentheses. Okay, that's where you type in 17. Okay, type in 17, close the parentheses, hit enter, and you should get 0.3053, whatever. Okay, basically you usually do 4 decimal places when you do a trig function like this. Okay, so that would be the total answer. You're done. Now the cosine of 62, you're going to do basically in the same exact fashion. You're going to type in your calculator cosine 62, hit enter. You should get 0.4695 when you round it to 4 decimal places. Okay, very, very simple. Now, this last one, we've got sine of A equals 0.8935. Right? If you have something like that, right, remember that these trig functions, right, only make sense if they're paired with an angle. Okay, so sine of this certain whatever angle A, we don't know, is going to be 0.8935. Right, so if you typed in sine of whatever this angle is, that's what your calculator will give you as the answer. Okay, so basically to get rid of the sine function, to get rid of any of these trig functions, to find the angle, okay, basically to get that sine to the opposite side of the equation, we have inverse sine functions. Okay, inverse sine, inverse cosine, inverse tangent. So it looks like this, right? A equals, you're going to have the inverse sine, sine negative 1 of this 0.8935. Okay, so the way you type this in your calculator, if you look at it, find those sine, cosine, tangent buttons. You should see inverse sine, inverse cosine, inverse tangent right above them in like blue or some different color. Right, so that means you hit the second button and then click whatever one of those trig ratios you're looking for. So we're going to hit inverse sine for this one. Then you can type in 0.8935, close your parentheses, hit enter, and the answer it gives you is that this angle A is 63.3 degrees. Okay, and a way to check your answer is then you could type in sine is 63.3 degrees, and if you hit that, you should get something close to 0.8935. Okay, I got 0.89333713, lots of things. All right, that's just the calculation portion. Now we're going to apply this. Okay, so we're going to solve a couple right triangles here. This first one, number 4. Right, like I said, you're always going to be given basically 3 of the 6 things. So for this one, in order to totally solve the right triangle, we need to find angle A, angle B, angle C, right? And then I usually, and most people do this, right, just name the side length opposite the angle, the lowercase version of that letter. Okay, so side A is going to be over here, side B is going to be over here, side C is going to be right there. All right, so that way you can find side A, side B, side C. All right, fill in the ones you know already. So we know that angle C is 90 degrees because we've got our right angle thing there. We know that angle A is 40 degrees. And we know that side B is 6. Okay, now you got to find these angles and these sides, right? Well, the easiest thing to do is to find that third angle, right? Because we know that all the angles of a triangle add up to 180. We've got 90, we've got 40. Okay, so you could subtract them from 180, and you're going to get angle B equals 50 degrees. That's a bad 5, 50 degrees. Okay, now to find side A and side C, okay, we have to use our trig ratios because we don't have special right triangles here. It's not 30, 60, 90 or 45, 45, 90. And we don't have 2 sides, so we can't use Pythagorean theorem. So we have to use our trig ratios. All right, so what we have to do here is set up one of the trig ratios. Now, I'm going to use angle 40. Okay, you could also do this with angle 50. It's going to look a little different, but you're more than welcome to do that. Okay, if I'm going to use angle 40, and I have to use side 6, I can find angle A and or side A and side C. Okay, so I'm going to work with A first. Right, in order to find A, we got to label these sides based on angle 40. So this angle right here, this is the hypotenuse, obviously. This is the adjacent side. That's the opposite side. Okay, so if I'm going to use B and A from angle 40, I'm going to have opposite and adjacent. All right, well, from SOHCAHTOA, which one of these trig functions has opposite and adjacent? Well, that's going to be the tangent. So tangent of 40 degrees equals A over 6. Okay, now to solve for A, all we have to do is multiply 6 to both sides, so we'll have 6 times tangent of 40 degrees equals A. All right, plug that right in your calculator to get A. So you just type in your calculator, 6 tangent 40, enter. And you should get that A equals 5.0. Okay, 1 decimal place is fine, so A is 5.0. Now, once you get this A, right, now we can really make a decision. It's totally up to you what you want to use to solve for C. To solve for C, you could, of course, use another trig ratio, so we could do the sine of 40 or the cosine of 40, or same with 50, right? But since you have 2 sides, we can also just use Pythagorean theorem, okay? So to do Pythagorean theorem, we're just going to use 5 squared plus 6 squared equals C squared, okay? 5 squared is 25. 6 squared is 36. Okay, so C squared equals the square root of, or well, C squared is equal to, let's see, 61. And square root both sides to get C equals the square root of 61. So C could be the square root of 61, or when you get to the solving problems, all right, I'm fine with you giving me the decimal. Okay, so if you do the square root of 61 in your calculator, you're going to get a 7.8. Okay, and that is all 6 answers to solve that right triangle. Okay, so we have everything. Now, number 5, very similar. Okay, but it's probably easiest to get the sides in this one and hardest to get the angles, opposite from last time. All right, so we know we have a right angle here. Right, we don't have these vertices labeled, but you're more than welcome to do that if you want. You don't have to. Okay, but we could find all these angles and all these sides. Okay, so how can we find this third side here? Well, we have a right triangle. We've got 2 sides. We could, of course, go right to the Pythagorean theorem and get that. So we'll have 10 squared plus 9 squared equals C squared. All right, so we'll have 100 plus 81 equals C squared, and C squared equals 181. The square root of that, okay, you can do it in your calculator, is 13.5. So you can fill that in right there on the triangle. All right, there's one of our answers. We still got to find 2 more answers. We got to find this angle and this angle. That's where it gets a little bit tricky because you have to use the trig ratios. okay? So I always suggest, okay, in order to find one of these angles, use whatever two sides were given to you, okay? Because this third side that we just found is a rounded answer, okay? Unless you give me this, use this as square root of 181, that's an exact answer, but 13.5 is rounded. So that means if you use 13.5, then this is going to be a little bit off, and this is going to be a little bit off, okay? So we want to find from this angle right here, right, from the blue angle, label all these sides, right? We know the hypotenuse is 13.5, opposite is the 9, and adjacent is the 10, okay? So we want to use the 9 and the 10. We want to use the opposite of the adjacent. Which one of our trig ratios uses opposite and adjacent? Tangent. So tangent of x equals 9 over 10. Okay, solve it just like I showed you up top. Okay, so we got to use the inverse tangent function to get x by itself. So x equals the inverse tangent of 9/10. Type that in your calculator. Second tangent, 9 divided by 10, close parentheses, hit enter, and you should get x equals 41.98 degrees, which is basically the same as 42 degrees. Okay, round to 1 decimal place for that, that's plenty. Okay, so you'll round that up to 42, and now we can very easily get our third angle. Okay, to get our third angle, you just do 42 plus 90, subtract that from 180, and you should get 48 degrees. All right, now we have all three of our sides, all three of our angles, so we have all of our answers right here. That right triangle is solved. Now lastly, we have just a quick word problem here. So during a flight of hot air balloon, right, we've got a little balloon, great, right, observed by two people standing at points A and B. They're exact opposite sides of the balloon, so we got B's over there, A's over here. Okay, now they're on the ground. Right, the angle of elevation from this point is, from point A is 28 degrees, so that's 28. Okay, point A is 1.8 miles from the balloon, so this has to be from the balloon on the ground. 1.8 miles, and we want to find the height. So we just have to set up our trig ratio, right? We've got a right angle there. Set up our trig ratio to find this height. Well, what do we have? We've got opposite and adjacent. Okay, so it's going to be tangent once again. So tangent of 28 degrees equals h over 1.8. Multiply both sides by 1.8. H equals 1.8 tangent of 28. Type that in your calculator, and should have 1.8 tangent 28. Hit enter. You're going to get h equals 0.96. Okay. All right. So 0.96 miles is how high this thing is. All right. The second part of this, besides finding the height, I also want you to know that point B is, that doesn't say away, 2.8 miles away from point A. So if this whole thing is 2.8, and we know this little part's 1.8, then we know that this side over here from B to the balloon is going to be 1.0, right? So 1 mile exactly away. And we already know the height is 0.96 miles. We want to know what the angle of elevation is. So we know this, and we know this, and what we want to find is this angle right here. Okay? So from this angle, what are these sides? Well, we've got the opposite is h, and the adjacent is 1.0. So we're going to use tangent again. Tangent of B, angle B, equals 0.96 over 1.0. So we got to use our inverse tangent function to solve for B. Inverse tangent, 0.96 over 1.0. Oops. That's really bad handwriting. Okay, type that in your calculator. Second tangent, 0.96 over 1. Hit enter. And B is 43.8 degrees. And you're done. You're all done right there. See you guys in class.